All right, rationals. So rationals are just like big, scary-looking fractions. So the first thing we start with here, and they work the same way as fractions though too. But the first thing we do is the least common denominator. So between 3 and 4 and 5 and 6. The least common denominator is the way that I think about it is least is smallest. So it's the smallest number you can divide both by. The smallest number that you can divide both of these by. So the LCD for 4 and 6, I'm going to just do this one. It is 12. And that is the smallest number. It is 4 times, or I'm sorry, did that backwards. The way you check it, like 12 divided by 4 is 3, and 12 divided by 6 is 2. And since there's nothing you can divide 3 and 2 by, you know that's the right answer. The way to get this, if you get stuck, this one down here is kind of harder. So let's see. So it's the smallest number that you can divide both into evenly. So if I was doing 9 and 12, I think the easiest way to do this is to take the bigger number, look at factors until the smaller number divides into it. Okay, so what I mean by that is take 12. 12 times 1 is 12. 12 divided by 9 does not work, right? No, Apple, I don't need you. 12 divided by 9 does not work, right? 12, that's a fraction. 12 times 2 is 24. 24 divided by 9 does not work. 12 times 3 is 36. Yes, 36 divided by 9 would be 4. So 36 would be my LCD. Okay. So you kind of divide it by 9 each time and see if it works. Okay, so you're trying to, if you take the bigger number, just keep, that's only really if you get stuck with one. There are some other ways to do it, but I feel like that's the easiest. I was trying to think. This doesn't hurt to do this once because it does help. So the other way to do it is you break it down into your factors. There is a reason I'm going to do it this way. Okay, so 3 times 3 is 9. 2 times 2 times 3 is 12. You write what they share once, and then you write everything else twice, or write everything else. So you write what they share once, and then you write everything else that they have there. So 3 times 3 times 2 times 2 would be 36. But if they share it, you only write it once. Okay, that we will use that concept later on. All right, solving the big scary looking fractions. We actually kind of have done this before. It should look very familiar to you. Like 8x to the 5th and 4x squared. So this is more like exponent rules, but this is a rational function or a rational expression. So do 8 divided by 4 is 2. You got 5 x's on top, 2 x's on the bottom. So you got 3 x's left over on top. Okay, so you can write those out if you need to. Okay, you got 3 x's left on top. Some of this, it does kind of start with some of the stuff you've seen before, though. I feel like you've seen this one before, too. 12x cubed y to the 4th z over 3x squared yz squared. Okay, so something like this. Again, look at my numbers, look at my x's, look at my y's, and look at my z's. So 12 divided by 3 is 4. 3 x's on top, 2 on the bottom. I have 1 extra x on top. 4 y's on top, 1 on the bottom. I got 3 extra y's on top. 1 z on top, 2 z's on the bottom. I got an extra z on the bottom. Okay, so go through it like that. If you need to write them all out, you can. This is just like the exponent things that we did before, so I'm only going to do one of those. When we get into this, so I told you we did factoring last week, and there will be some factoring this week, or right now in a minute. But when you get done with the factoring steps, what you can do is look for being able to cross these out. So these are different factors. They're looked at as one. You got two factors on top, two factors on the bottom. If you have the same, you can cross those out. Okay, so I have x plus 3 on top and x plus 5 on the bottom left over. Do not cancel that out, okay? You can only there are 4 terms here, right? X and 3 and x and 5. You can only cross something out if all 4 terms are your answer. So they do not share an x, only 2 of them share an x. So that is my answer, okay? So I'm going to write this. I shouldn't even write this, but no, do not do that, okay? No, do not cross out the x's like that. There's 4 terms there, and they all have to have an x. So we will do a ton of that. What's this one? X squared times x minus 1 cubed over x minus 1 times x squared squared. Okay, so this one's kind of strange. But we can change x squared squared right here. This is actually x to the 4th. That's probably the easier way to think about that. That's x to the 4th. But the thing here that you're going to run into the most, well, let's go ahead and do that. You have 2 x's on top and 4 on the bottom. So you end up with 2 extra x's on top or on the bottom, right? 2 x's on top, 4 on the bottom. So you got 2 extra x's on the bottom. But this still works right here. You've got 3 of these on top and 1 of these on the bottom. 3 of those on top and 1 of those on the bottom, so you have 2 extra on top. You can still do that even if it's a binomial and factor it like that, okay? That x minus 1, you have 3 on top and 1 on the bottom, so you can cancel those out. And don't think you'll run into that like too much. All right, so the easiest way to do these when you start simplifying is to simplify the top, simplify the bottom, and then cancel the stuff out. So if on the top, I could pull out a GCF of did they make this a weird one? Well, let's just see. I can pull out a 6x. So I have x minus 2. Right? So remember, you can multiply it back through. 6x times x would be 6x squared. 6x times negative 2 would be negative 12x. And then I have a 3x. Okay? Now, these right here you can simplify because that is being distributed through all of that with the parentheses there. So the x would cancel out, and 6 divided by 3 would be 2. So you have x minus 2. Now, one of the weird things that happens with rational is that we do not have to distribute that back through. We can just leave our answers in factors because that's kind of the way we had it. But when you do these, you want to simplify the top and then simplify the bottom and then see if something cancels out. So on this one, I have 9y cubed plus 18y squared over 3y squared. So on the top in the numerator, I could factor out a 9, and they both have at least 2 y's. So that leaves me with y plus 2 divided by 3y squared. And again, I could simplify these. So that 9 divided by 3 is 3. Y squared and y squared cancel out. So it is 3 times y plus 2. Yeah. If you are ever working a problem and you get down to something like this, if you have the same thing divided by the same thing, the answer is 1. Right? X plus 3 divided by x plus 3 is 1. If I do 10 divided by 10, it's 1. Anytime you divide the same thing by the same thing, it is 1. They don't cancel out and like get 0, you get 1. On something like this, see how this one works out? Well, let's rewrite. What if I rewrote the denominator as negative x plus 5? Okay, not quite the same thing. What if I pulled out a negative 1 and made that positive x minus 5? Okay, so anytime you have a positive x and then a negative x, a lot of times you're going to like pull out a negative 1 to see if they match. So now this is like having a 1 on top and a negative 1 on the bottom. Those cancel out. 1 over negative 1 would be negative 1. So anytime something like looks close or there's just a negative, like this is positive and this is negative, you do pull out a negative. And that makes life a little bit easier, and usually something will cancel out. So we're kind of going through all the basics of the different ways to simplify these right now. And then we're going to put them all together. Okay, so on this one, when you get to harder ones, rational fractions or rational expressions are just big, scary looking fractions. They got x's on top, x's on the bottom, but you just have to work it as like two separate problems. Simplify the top, simplify the bottom, and see what cancels out. So for my top one here, so for this one, this is a factoring problem. What multiplies to be 6 and adds up to be 5? My answer is going to look like this. The bottom, I can't do anything. It's just x plus 3, right? So it's what multiplies to be 6 and 5. So 3 times 2 is 6. 3 plus 2 is 5. So I write x here. X times x is x squared. 3 times 2 is 6. 3 plus 2 is 5. So I simplified the top. The bottom I can't really simplify, so I just rewrite it. But once you do that, something will probably cancel out. And my answer is just x plus 2. So I had an x plus 3 on top and an x plus 3 on the bottom. They cancel out. And I get x plus 2. All right, so again, we want to simplify the top and then the bottom. So on my top one here, x squared minus 9. Hopefully you remember if you can do the square root fast in your head. It is a special factoring. So x times x is x squared. 3 times 3 is 9. And then since there's only two terms, they add up to be 0. 3 times negative 3 is negative 9. 3 minus 3 would be 0. It's called the difference of squares. Anytime you have that one, you put a plus and a minus in the middle. Okay. And then on the bottom, x squared plus 3x, they both have an x in it, right? So I could factor out an x and get x plus 3. So now I have an x plus 3 on top, an x plus 3 on the bottom, and I'm left with an x minus 3 on top and an x on the bottom. Again, you do not cancel out the x's, because you have 3 terms here, 1, 2, 3, and all 3 do not have an x. All right, so anytime we learn something new, I think I talked about this when we did polynomials, but you go through adding, subtracting, multiplying, and dividing. So the rational right here kind of starts in multiplication, but we will go, anytime you learn a new set of numbers, you always do this, the adding, subtracting, multiplying, and dividing. So when you multiply fractions, I'm always probably going to do this on these problems, but it works the same way as fractions. They're just big, scary looking fractions. So when you multiply fractions, you just multiply straight across, right? You put the bar like this. You do 2 times 4 is 8. 3 times 5 is 15. So this is going to work the same way. I'm just going to take this bar across, and I am going to multiply straight across. So if I combine all these, I do 12x squared y z squared. 3 times 4 is 12, and then x, y, z. And now this looks like a problem we were working a minute ago. Sorry. Scroll there. Where you look at your 12, your numbers, your x's, your y's, your z's. A lot of stuff cancels out here, doesn't it? 12 divided by 12 is 1. 2 x's on top, 1 on the bottom. So I got x. The y's cancel out because 1 on top, 1 on the bottom. The z's, there's 2 z's, and on top, 1 on the bottom, so there's 1 extra z. So this becomes just x and z. So on these, you can just multiply straight across and then simplify. X plus 2 divided by x times x minus 1 divided by... That one is not helpful. I think I need to do some changing of the problem here. Let's change this to 2. Okay, so if you had something like this, same idea. I am going to multiply straight across, so it just becomes like 1 bar. Well, now what happens here is the x plus 2 is on top and the x plus 2 is on the bottom. They cancel out. So I have x minus 1 over x minus 3. So you can, what happens when you multiply is you can kind of look at the whole top and the whole bottom and see if anything simplifies there. I changed that to 2 because nothing was going to cancel out. If you do these correctly, like almost always, something's going to cancel out. Kind of scared my chat GPT problems or whatever AI used to do this is going to make them not cancel out, but I think stuff should cancel out. Okay, so on this one, again, you got the top, the bottom. You got 4 different things to look at here. So you kind of simplify everywhere you can. In the upper left, okay, upper left, I have x squared plus 3x plus 2. So that is a factoring problem. What multiplies to be 2 and adds up to be 3. That would be, what, 2 times 1 is 2, 2 plus 1 is 3. So my upper left would be x plus 2 and x plus 1. X times x is x squared. 2 times 1 is 3. I'm sorry, 2 times 1 is 2. 2 plus 1 is 3. In the upper right, that's just x minus 3. I can't do anything, right? So I just rewrite it. In the bottom left, that would just be x minus 1. Change my colors here so you know which one goes with which. That one's red, that one's blue, that one's green. This one will make purple. Seriously. Okay. In the bottom right, x squared minus 4. That's a perfect square, right? 2 times 2 is 4. X times x is x squared. And when you just have two terms, you put a plus and a minus. Okay. So you, on this one, I said a minute ago, you simplify the top, you simplify the bottom, and then you see if stuff cancels out. On this one, you got to simplify 4 things. Simplify the top left, simplify the top right, simplify the bottom left, simplify the top right, and then see if stuff cancels out. So this cancels out with this. Is that the only thing that cancels out? That's kind of sad. So every once in a while, there's just one thing that'll cancel out, but usually a bunch of stuff cancels out. Which one is this topic? Multiplying rational expressions with leading coefficients of 1. Let's see if I can get an Alex problem here to see how much they cancel out. No, I didn't do multiplying. I did. All right, x squared plus x minus 6. X squared plus x minus 6. Although, let's make some colors here. Four x plus 8. X squared minus x minus 6. And x plus 3. Okay, so on this one, you are multiplying both of these. Okay, so it looks like this to start, but when you multiply both of these, what you're really doing is just doing the whole thing across. So in my red one, upper left, I'm looking at what multiplies to be negative 6 and adds up to be 1. Right, there's a 1 right here in front of the x. So it would be what? Plus 3 minus 2. So this is where I was talking about last week, how factoring is very important to be able to do these good. Like there is 2 factoring problems, 3 factoring problems built into these. There could be 4 factoring problems built into these. So x times x is x squared. 3 times negative 2 is negative 6. 3 minus 2 would be 1. In my blue one, I could upper right, I could factor out a 4, right? Make it x plus 2. So even if it's just a GCF, you can factor that out. In my green one, what multiplies to be negative 6 and adds up to be negative 1? This should be the same thing with opposite signs, right? Negative 3, positive 2. So x times x is x squared. Negative 3 times 2 would be negative 6. Negative 3 plus 2 would be negative 1. And then my purple one, can't do anything with that. That's just x plus 3. So you have to work 4 separate problems on these. Upper left, upper right, bottom left, bottom right, and then simplify. Okay, so these problems are long. All right, to simplify, x plus 3, x plus 3, x plus 2, x plus 2. So we are left with 4 times x minus 2 and x minus 3. So that whole problem simplifies down to just that right there. Like I said, when you work these out, usually at least one thing's going to cancel out. Usually it's like 2 to make it a much smaller problem. Sorry, I don't think that's... Yeah. Oops. All right. All right, so that's multiplying. When we go to dividing, well, always, if you forget what to do, always think back to fractions. Write it out real quick. divided by. Okay, think back to fractions. If I think back to fractions, 2/3 divided by, I don't know, 5/7. Anybody remember how to divide fractions? Keep, change, flip. Or keep, switch, flip, keep, change, flip. This is multiplying by the reciprocal. So you keep the first one like it is, you change the sign to multiplication, and you flip the last one. When you divide by a fraction, you multiply by the reciprocal. So we are going to flip the second one. And then you do the same thing as what you would do, 14/15. Okay? So when we do, as soon as we see this divide sign, we think keep, change, flip. Okay? So like if I was rewriting this problem, I would write keep the first one like it is. Change it to multiplication, so I drew the bar all the way across, and flip this one. Flip the second one. So now let's multiply. You can kind of simplify first on these, but I think it might be easier just to multiply and do it. So 8 times 10 is 80, x3, y, z squared. 5 times 4 is 20. 1x, 1y, 1z. So 80 divided by 20 would be 4. 3 x's on top, 1 on the bottom, so you got 2 extra. 1y on top, 1 on the bottom, they cancel out. 2 z's on the top, 1 on the bottom. So you get 1 extra z on top. There's nothing on the bottom, so I just don't write anything. All right, let me pull this problem. 8, 7x plus 3. Did I say 7x plus 3? 63. 2x, x plus 9. Okay, so on this one, again, as soon as I see this, I'm writing on my paper or whatever, thinking flip the second one. So this is going to turn into a multiplication problem. We can kind of simplify as we're doing this. On the left side, it would be 8. All right. On the left side, it would be 8. And then on the bottom, I could factor out a 7, so I don't have to write it down twice, right? I could go ahead and 7 and 63 are both divisible by 7. On the right side, the x plus 9 comes up here. And my 2x comes right here. So I had to flip that last one. But it's okay if you're going ahead and like simplifying these as you're flipping them. That saves you a little bit of time here. So now x plus 9 cancel out, and I have 8 and 14x. You can divide both those by 2, so it would be 4 over 7x. All right, divide by 2, divide by 2. Sorry, I know you probably started writing, but I'm going to Alex because that's not going to simplify. X squared minus 4x plus 3. x minus 2, x plus 3. 3x minus 3. Okay, so on this one, again, as soon as we see this, we're thinking we need to flip this sign. Why does it do that? The new iPad update has been giving me troubles today. All right, so upper left, that's a factoring problem. What multiplies to be positive 3 and adds up to be negative 4? That'd be negative 3 and negative 1. So x times x is x squared. Negative 3 times negative 1 is positive 3. Negative 3 plus negative 1 would be negative 4. Bottom left is just x minus 2. Upper right, we have to flip it. So we would put x plus 3 up here. And then bottom right would be this one right here. We flip it, right? So we could factor out a 3, and it'd be x minus 1. So make sure you flip that second one when you see divide. X minus 1 cancel out. Is that the only thing that cancels out? That's kind of sad. X minus 3, x plus 3, 3, and x minus 2. You do not have to, I hadn't said this really yet, but everything we deal with in rational world is in factors, so you don't have to FOIL those back out or anything. That is your answer. All right, so multiplying and dividing works very similar. Just when you see that division sign, make sure you flip the second one. Because you're multiplying by a reciprocal. Adding and subtracting is probably the hardest one, just because adding and subtracting fractions is not fun either. So finding the least common multiple. This is like the least common denominator. Like if these were your denominator, how would you find the least common multiple? So for the least common denominator, or multiple, we can put multiple here since this is talking about multiple. We know how to do the numbers. Okay, we did that before. Like somebody already said 24. But for the variable, it's the highest thing you can divide both of them into. So I need the biggest exponent. Okay, if you remember, GCF was the smallest exponent, and LCM is the biggest exponent. So somebody already said 24 for my numbers, right? 24 divided by 6 is 4. 24 divided by 8 is 3. So we're good there. That's the way to check it because you can't divide 4 and 3 by anything else. But for my LCM, for the variables, what you do is you take the highest exponent. Okay? You got to be able to pull all of those from there, or you got to be able to divide all of those out. So I need the highest exponent. We'll do this one just because. So 10y to the 4th and 15y squared. What's my number? What's the least common multiple? 10 and 15, what? 30. So again, you can check it by dividing both of them. 30 divided by both of them, that's 3, that's 2, so that's good. If there's not a number there. What it looks like, I was trying to think of a good example here, and I can't. Let's say you had 6 and 12, and you chose 24. Well, 24 divided by 6 and 24 divided by 12 leave me with 4 and 2, right? Well, 4 and 2, I can divide both those by 2. That means I should divide that by 2 to get my least one. I didn't choose the least. If I can divide both those by something, then that means I didn't choose the least one. That's why I always do this to check. So 3 and 2, I can't divide by anything besides 1. So that means I do have the smallest common denominator, if that makes sense. If you ever divide it out and you get a number where you can divide both of them by 2, that means you didn't choose the least one. So my least common denominator here is 30 y to the 4th. You take the biggest exponent. On the next one, if you have multiple variables, it doesn't matter. You still just take the biggest one of each one. What's my least common multiple of 12 and 18? Again, if you get stuck, 8 times 1 is 18. 12 doesn't go into that. 8 times 2 is 36. 12 does go into that, right? So it is going to be 36. So 36, I have 3 x's and 2 y's. You take the biggest exponent. All right, so one of the things you got to do with fractions is write the equivalent fraction. No, I'm going to go pull this from Alex. Write an equivalent fraction. How do they do it? I thought so. 5 and 6u. Okay. All right, so on this one, you have to do equivalent fractions. So, like, I'll do an easy fraction one over here. Like, if I had 1/2, but I needed a common denominator of 10, then half and 10, how do I make that be the same? Most of y'all kind of know half, like 5 is half of 10, right? But what you're really doing here is you're saying, okay, 2 times 5 is 10. So if I multiply the bottom, I have to multiply the top too by 5. So it's the same thing you're going to do here. We're going to find the least common denominator, so we'll know this number, but how do I make this number be this number? Well, I would take it times 4, and then it needs 4 more u's, right? Because there's only 1. So 6 times 4 would be 24. We have 1 u, we need 4 more u's. If I multiply the bottom by 4u to the 4th, then I need to multiply the top by 4u to the 4th. So that becomes 20u to the 4th. So don't forget what we're doing here. We are not changing the problem. These are actually the same fraction because it's just a different denominator. I think I'm going to do that one more time. That's like the same numbers. 7, 6w. $36. Okay. So how do I go from 6w to 36w7? I would multiply by 6, and I got 1w here, so I need 6 more. So now I multiply the top by 6w6. So that would be 42w6. We'll continue to do that a bunch, so. Common denominators. Common denominators are easy because you keep the denominator the same and you don't have to do any of that stuff we've been going over right now. So all you have to do is add the numerators. 3x plus 2x would be 5x. I guess we could simplify the 5s there, right? We could cross those out, but so common denominators are always easier with fractions because you just add the top. Not that I need to do a ton of these, but so 4a plus 5a, 4a plus 1a would be 5a, and then the denominator stays the same. So make sure you keep those the same. The denominator should always be the same. Another one with the same? Common denominator, okay. 2x over 3y squared plus 5x over 3y squared. It does not matter. I did not do my example here. Oh, that doesn't work. Oh my goodness. Sorry. It does not matter what is in the denominator. Okay? You keep the denominator the same all the way to the bottom, and you just add the numerator. So it does not matter that you have 3y squared. It's the same on all of it, so it stays the same. And then you add the numerator. 2x plus 5x would be 7x. So we add these the same exact way. Adding rational expressions with common denominators and binomial numerators. Oh, wait, maybe I shouldn't have deleted that. Yeah, we can do that one, okay. So 2x minus 5 over x plus 4 plus x plus 1 over x plus 4. Again, it does not matter what is on the denominator. If it is the same, you keep it the same all the way throughout. Now you just combine like terms. 2x plus x would be 3x. Negative 5 plus 1 would be negative 4. And we cannot simplify this at all because there are 4 terms. 1, 2, 3, 4. They all have to have a 4 in it. They all have to have an x in it. They all have to have something the same to be able to divide it. That one I'm going to go find. Adding rational expressions with common denominator, GCF factoring. Okay. 7z plus 1 over 4z. I'm not doing z. 7z plus 1 over 7z. Over 4z, wasn't it? I don't want to do 4s or z's and 7s. 9, negative 5, 4. All right, so nothing different here. Same denominator, so you just use the same denominator. 7x plus 9x is 16x. 1 minus 5 would be negative 4. Now what happens here is you can simplify. You always want to check. The top, I take out a 4 on the top and get 4x minus 1. So now I do have a 4 on the outside here. Those cancel out, so I have 4x minus 1 over x. The other way you could do it is divide all 3 of those by 4. Because that's what I've been saying all along. Unless you can divide every term in there by something, you cannot simplify it. But I can divide all those by 4. I am scared those are not going to work out the way we want it to. So, again, let me go get a problem. x squared minus 8x plus 15. Mm. 5. Oh, this is a minus, which is fine. Like, it doesn't really change anything we do. We just subtract instead of add. Okay, so when I do this one, anytime you see something like this on the bottom, you should probably just go ahead and factor it. So what multiplies to be 15 and adds up to be negative 8? So it should be minus 3 and minus 5. Right, so my denominator is actually x times x squared. Negative 3 times negative 5 is positive 15. Negative 3 minus 5 is negative 8. So these are all the same denominator, right? The reason I'm going to go ahead and factor that is because, well, now I do my numerator, x minus 5. And look at that, they cancel out because I have x minus 5 on top and x minus 5 on the bottom, so you get 1 over x minus 3. So you can factor it at the end if you want to, but anytime you have like an x squared and x on the bottom, you're going to end up factoring it because something's going to cancel out there. All right, so everything we've done so far has had the same denominator, 1/3 plus 2 over y. What happens if you have different denominator? We only have 3 topics like that, so it shouldn't be too bad on those. First thing you always need to do is find your least common denominator. On this one, it's just going to be 3 and y. So I need to turn both of those fractions into a denominator with 3y. Okay? So to go from 3 to 3y, I need to multiply the bottom by y, so I multiply the top by y. To make this one look like this, I need to multiply it by 3. So I multiply the top by 3. Now it's just like we've been doing. 3y is on the bottom, and I have y plus 6 on top. So you have to come up with the least common denominator, and then you have to make both the denominators look like that least common denominator. Okay, these are fine. Just trying to make sure the problems that I'm doing are matching what you're doing in the homework. 2 over 3x plus 5 over 2x. Okay, what is my least common denominator here? Anybody? What about 3 and 2? What's the least common denominator of 3? Is 6, and then the biggest exponent is just x. So it is just 6x. So how do I go from 3x to 6x? I would multiply by 2. So I need to multiply the top by 2. How do I go from 2x to 6x? I multiply by 3. So I need to multiply the top by 3. The denominator stays the same. 4 plus 15 would be 19. All right, last topic in this section. is what do we do if we have bigger numbers? Same idea though. Least common denominator on this one, 4, and then you take the biggest exponent, so 4x cubed. All right, so to go from 2x squared to 4x cubed, I'm going to multiply by 2x, right? So I multiply the top by 2x, so that would be 6x. And then this one is already the same thing. If it's already the same thing, you just rewrite it. So my denominator stays the same. And my top I add together, 6x plus 5. Let me double check that one on Alex real quick just to make sure, but I'm pretty sure that looks the same as what we were doing or what you're going to do. Let's do this one with a negative in it. Negative 7 10w squared. And we're probably not done, sadly. As I hear you packing up, 5 over 6w cubed. Okay. Common denominator of 10 and 6 would be... Is it 60? 60 seems big, so let's go check it. 60 divided by 10 is 6. 60 divided by 6 is 10. That's not right then, right? Because you can divide 6 and 10 by 2, right? So it shouldn't be 60, it should be 30. That's how you check that. So 30, and then I have 3 W's, so I need 3 W's. All right. For the left side, to go from 10w squared to 30w cubed, I need to multiply by 3w. So I multiply the top by 3w. So that would be negative 21w. For the right side, to go from 6w cubed to 30w cubed, I need to multiply by 5. So I multiply the top by 5, and I get 25. So now you keep the denominator the same. And negative 21w minus 25 because it's subtraction. 21, 25, and 30. No, I cannot divide those by anything. So you have to come up with the least common denominator, and then you have to multiply each of these denominators to make it match that, which multiplies the numerator as well. It's a lot of topics.